Take a high-value, fiercely competitive luxury real estate market like the sprawling South Bay coast of California. When a buyer searches for luxury homes here, they no longer see a list of links. Instead, the interface instantly generates an AI overview that dominates the screen. Because the answer is synthesized right on the page, 60% of all searches now end without a single click. This chart tracks the immediate fallout from Google's infrastructure shift. At this point, traditional Position 1 organic traffic drops by an average of 58%. Surviving this environment requires a departure from traditional search engine optimization, moving toward a new discipline, Generative Engine Optimization, or GEO. In this new environment, the machine acts as the primary gatekeeper. If an AI cannot parse your information, a human reader will never have the chance to see it. The shift became permanent at Google I/O 2026 with the deployment of the Gemini 3.5 Flash model. This rollout triggered an authority decoupling. Legacy websites that spent a decade building highly trusted domains lost their search visibility almost overnight. We can see exactly where the new citations originate on this hierarchy diagram. Notice how these data nodes from positions 11 and below bypass the top 10 results entirely. Currently, 38% of all AI citations are extracted from page 2 or lower. This trend demonstrates that a domain's historical authority is being bypassed by a new set of structural priorities. To become retrievable, you have to understand how Gemini processes information. It doesn't run a single search. It uses a mechanism called query fanout. Looking at this model of a complex query about South Bay real estate, the AI instantly fractures that single prompt into dozens of parallel subqueries. It simultaneously hunts for specific variables, median price, local school districts, and commute times to major employment centers. Once it retrieves those distinct data points, the system merges them back together into a single, synchronized generative snapshot. If your website only answers the initial query, you lose the citation. You must preemptively answer the follow-up questions within your content architecture. Content clusters that resolve an entire fanout thread provide the AI with everything it needs in one location, establishing that domain as a preferred core source. Getting the crawler to your page is only the first step. The way the machine analyzes your text determines if you actually get cited. AI models exhibit an extreme document position bias. Search engineers refer to this as the ski ramp effect. Looking at this topological overlay of a standard web page, the extraction probability is heavily skewed. The top 30% of the document accounts for 55% of all citations. AI crawlers operate on strict latency budgets. If the answer is buried deep on the page, the model runs out of time and abandons the extraction entirely. Traditional content marketing often relies on a narrative opening to warm up the reader before delivering the core information. That approach actively prevents machine retrieval. Front-loading definitive answers is now a strict technical requirement. You also have to change how you write the actual text. Keyword density is outdated. LLMs now measure pages by fact density. Fact density is the exact number of verifiable, unique data points contained within a single paragraph. Take a standard SEO approach. A writer might describe a coastal city as a beautiful, upscale community known for stunning ocean views and a peaceful atmosphere. Compare that to a GEO-optimized version. It states homes range from $2.1 to $6.5 million, average 3,200 square feet, and sit 2.3 miles from a medical center. The retrieval engine skips the first version because subjective adjectives cannot be cross-referenced or verified against the knowledge graph. Conversely, when you anchor your text with hard statistics and explicitly name your sources, extraction probability essentially doubles. The algorithm only rewards verifiable facts that it can synthesize. To guarantee that your facts are extracted, you package them into a specific architectural framework called the Q block. Step 1 is the heading. As we see in this component blueprint, it must mirror the conversational phrasing of the user's prompt, formatted as a direct question. Step 2 is the direct answer. Placed immediately beneath the heading, this is a bolded, declarative statement kept strictly under 300 characters. Step 3 is the expansion. You support the direct answer with a quantitative data table or a structured bulleted list. If the query asks about Palos Verdes cliffside properties, the Q block immediately delivers median prices and square footage before expanding on local HOA fees and school ratings. The Q-block works because it mimics the structured training data, like Wikipedia and medical databases, that these models were originally built to process. The most common fear among marketing directors is the sheer loss of total traffic volume as zero-click searches increase. But this divergence chart shows what happens when domains transition to AI-native optimization. The optimized sites experience an 8.4 times increase in citation visibility over their competitors. The traffic that clicks through behaves differently. AI overviews act as a qualification filter, ensuring only high-intent users leave the Google ecosystem. Research confirms that users clicking through an AI citation convert at a 23 times higher rate than traditional organic cohorts. Capturing a lower volume of deeply pre-qualified AI traffic is ultimately more profitable for enterprise businesses than generic clicks. The fundamental shift in digital strategy is clear. Marketers must stop pleasing humans and start programming for the machine. Winning requires strict adherence to the tactical triad. Implement rigid Q-blocks, maximize fact density, and place all definitive answers in the top 30% of the document. Audit your high-value landing pages today. Cut the narrative fluff and replace it with structured, verifiable data. In 2026, the algorithm rewards structure, facts, and retrievability.